Hello students, today we are going to learn about electric fields and electric forces. To begin with, we will be studying about origin of electricity. So from where does the electricity comes? Okay. So if we talk about atoms, its atomic structure, the electrical nature of matter is inherent. Okay. So an atom consists of a small but massive nucleus, which you see over here. This is the nucleus, right? And this is the nucleus. And it contains particles called protons, which you see over here. These are the protons carrying the plus charge. And it also contains neutrons, which do not contain any charge, which are neutral. As the name suggests, neutron, they get their name from the neutral charge because they don't carry any charge. A proton has a mass of 1.673 into 10 to the power minus 27 kg. Okay, and if you look at neutron, it is slightly greater in mass, which is 1.675, slightly greater, into 10 to the power minus 25 kg. Surrounding the nucleus is a diffuse cloud of orbiting particles that are called electrons. So if you see over here, so these electrons, they surround the nucleus, and these are these particles, electrons. They carry negatively charged charge. And if you look at the weight of or mass of electron, it is 9.11 into 10 to the power minus 31 kg. So as we are talking about mass, okay, as mass is the inherent or intrinsic property of this atom, similarly charge is also, the electric charge is also the intrinsic property, because these particles, they have these charges, okay, like proton carries plus charge, electron carries negative charge. Excuse me. Um, okay, so this is the intrinsic property, the electric charge. So there are two types of charges we can conclude as we have studied over here. One is positive and the other one is negative charge. Okay. A proton carries the positive charge and the electron has all the negative charge. And if you talk about neutron, it has no charge. Okay. So here we discussed about the atomic structure and the charges. Now moving on, we have this thing. When an atom or any object carries no net charge, that object is said to be neutral, right? So what do we call that object as? Electrically neutral, because it do not contain any charge. Neutrons in the nucleus are electrically neutral particles. So if we just studied that if you see the nucleus, these are your protons, and let's say these are your neutrons, they do not carry any charge. So these are neutral particles. Charges of larger magnitude than the charge on an electron or a proton are built up on an object. Let's say you have a metal slab, okay, and then it contains a lot of charge, okay. Let's say 25 coulombs, 50 coulombs, and this charge is built up on this metallic plate, right? Then how do we calculate that charge? How do we keep track of the electrons? How many electrons are here? So charges of larger magnitude, other than as compared to the charge on electron, as compared to the charge on proton, so it is built up. So how it is built up? By adding electrons. How you can increase the charge? By adding electrons over here. Or also you can remove the charge by removing electrons. We can remove electrons, okay, and then if we want to remove the charge from this object, the magnitude of any or the magnitude any charge of magnitude q is an integral multiple of electron, okay. So as we are saying, some charges being built up, let's say I'm putting 10 electrons over here, so how much charge is built up? How do we keep track of it? By using this simple equation, charge, which is denoted by q, is equal to n times e, okay, where what is n? N is an integer, it can take any number, okay. So because it cannot be half, okay, it cannot be 1 over 3. Okay, so half electron doesn't travel, 1 over 3 electron doesn't travel. So basically fractions are not allowed. So because any electric charge Q occurs in integral multiples of elementary indivisible charges of magnitude E, electrical charge is said to be quantized. So this is called quantization. Okay. So because you can't transfer any fraction of electron, you can only transfer 1 electron, 2, 3, 4, and so forth. So this is called quantization. Okay. Now moving on, you can also practice few questions solving on this equation as we have over here. The first question: how many electrons are there in 1 coulomb of negative charge? Okay. So what is given to us? The charge is given to us. Okay. So Q is equal to 1 coulomb. This is given to us. Right. So how many electrons will be there? So we are trying to find the n. We are looking for n. Do you know the equation? Which equation to use? Yes, we know this. We just studied. We want to use this equation. Okay, so let's try to plug in the numbers over here. Or let's first do this thing. Try to isolate this variable because we are looking for this n. So how do I isolate it? So n is equal to q per n. Okay, so we can do this thing. Okay. Now, Q is 1 coulomb, right? And what is the charge on electron? The charge on electron, always remember, it is 1.6 into 10 to the power minus 19 coulomb. Make sense? So you can go ahead and put this in your calculator, 1 upon 1.6 into 10 to the power minus 7. So which is 6.25 into 10 to the power 18. So these many number of electrons are present in 1 coulomb. Do you understand? Do you see how big number is this? 10 to the power 18. So 18 zeros, 6.25, and then you have 18 zeros. So 1 coulomb of negative charge contains 6.25 into 10 to the power 18. Okay. Now moving on, what do we have? Charged objects and the electric force. Okay. Now, why do we are studying all this? Because we want to charge objects, right? We want to make more use of it just rather than calculating the number of electrons that are being transferred, right? So how many electrons are there, or if you have number of electrons, what would be the charge? So electricity has many useful applications that have come about because it is possible to transfer electric charge from one object to another. Okay. So electricity, obviously, today we can't imagine our life. It has so many applications, useful applications. So it is all possible because it is possible to transfer electric charge from one object to another. Okay. Usually electrons are transferred and the body that gains electron acquires excess of negative charge. So as we begin our lecture, we told you electron carries negative charge. Now, if there is a body and you are trying to put electrons, so essentially what type of charge you are trying to put over here? Negative. Because electron, when it comes into this body, it carries with itself negative charge. So what is happening? Negative charge is being accumulated. Okay. So this body will have excess of negative charge. And let's say on the other hand, there is another body and you're trying to pull out electrons from that body. So what you're doing, you're pulling out negative charge from that body. So that body will be positive, right? Because you're taking all the electrons, what would be left? If you see the atom, the electrons are here, okay? Electrons are outside. And what is left? The positive charge, right? Neutrons do not carry. So that body will have excess of positive charge. Such separation of charges occur often when two unlike materials are rubbed together. Okay, so we will see some applications and some daily scenarios in which you can separate the charge. by rubbing two unlike materials, two different materials with each other. Now, moving on, let's get into the example what we have over here. For example, when an ebonite rod, which is hard black rubber rod, okay, do you see this in the diagram? This is, let's say, your ebonite rod, and it is rubbed against the animal fur. What is this material? Animal fur. What would you be expecting? Some of the electrons from the atoms of the fur are transferred to the rod. So from the fur, the electrons are moving towards the ebonite rod. Okay. So when you do this, electrons from the fur, they are transferred to the rod. This transfer gives the rod excess negative charge. So do you see this negative charge being accumulated on the ebonite rod? And what will happen, because this animal fur is losing those electrons, it will be essentially left, it will be having only positive charges. Okay, so this is separation of charges. Okay, so they will attract each other when you will rub them. Okay, similarly, if you have a glass rod, there's another example, and you rub it on a silk cloth, some of the electrons are removed from the atoms of the glass. Okay, so that means this is your glass rod, and let's say this is your silk cloth, and you're rubbing it. So electrons will be leaving the glass rod. Okay, and then what will be happening to the glass rod? It will be positively charged, and silk will accumulate negative charge. Okay, and there are so many other examples you must have done in your previous grades as well. Moving on, we want to take note of one thing over here. If you know it already, that's good. Like charges repel and unlike charges attract. Okay, so if you see the first diagram over here, this is the positive charge, this is the negative charge. Okay, they attract each other. These are unlike charges. What's the rule say? Unlike charges, they attract each other. And what about this situation? Two negative charges, they repel each other. Okay, and similarly these two positive charges, they will repel each other. Okay, now here are a few practice questions. What I want you to do is you can stop over here, give yourself, let's say, 15 minutes, 5 minutes for each question. Go ahead and try to solve them, and we can come back for a discussion. Okay,